On a flatbed such as this, the majority of welds are actually done in what we call the spray transfer mode. Spray is hot. Unlike short circuiting, we are welding at much higher amperages and much higher voltages. It's a different mode of transfer. You now need the right type of protective clothing. With spray transfer, you have to protect your arms, your neck. Any skin should not be exposed to spray transfer. With spray transfer, it's the hand that does the welding. You have to have good gloves for spray, particularly as you get into the higher amperages. And for a welding shield, you need at least a number 11 shade. This then is spray transfer. It's hot, penetrates deep, and you can weld on 1/8 plate to any thickness. Unlike short circuiting, it requires, again, a careful balance between the voltage and the current. On many applications, this may be too hot, so we back it down to a more form of globular transfer.
Determining when to set the power source for spray transfer is simple. If the steel is over 1/8 of an inch and the welding is done in the flat or horizontal position, set for spray transfer.
You know, spray transfer has its own requirements. But, like short circuit welding, we can make it simple. Let's look at the fundamentals required to get spray transfer. This particular power source is a 450 amp machine. As we mentioned earlier, it has two different types of tap outputs. If your power source says flat slope and steep slope, for spray transfer, set the setting at the flat slope. Or if it just provides a low amperage and a high amperage, make sure you put it on the high amperage tap. The output of that power source is designed to give you better response on that particular tap. What about voltage? Well, the voltage range for spray is 23 to 33, and quite simply put it in the middle. Start off at about 27, 28 volts. Amperage, 045 and 035, you generally have to be just above 200 amps to get good spray. To get 200 amps, you have to feed the wire through at about 350 to, well, anywhere up to 700 inches a minute. To attain optimum spray transfer with an 035 electrode wire, ensure the wire feed is set past 400 inches a minute or 10 meters a minute. The majority of spray applications will be welded with the wire feed set between the 3 and 4 o'clock positions. That's approximately 560 to 630 inches a minute, or 14 to 16 meters per minute. If the 035 wire feed setting is close to the 12 o'clock position, then globular transfer may occur. If the 035 wire is past the 4 o'clock position, you likely should be using a lower cost, larger 045 wire. Note the typical spray amperage range, and also note the required weld voltages. For all spray applications, start out with 27 to 28 volts. When adjusting your voltage, if you see weld spatter, increase the volts. The spray arc sound should provide a crisp, smooth crackle sound. If the spray sound is without the crackle, the arc length is too long. This usually results in undercut. Lower the voltage. Remember, with short circuit transfer in the 035 wire, 10 o'clock and 17 cups of coffee, Well, it's just as easy when welding spray transfer. Set the wire feeder at the 3 o'clock position. 27, 3 o'clock, 27 cups of coffee. 3 o'clock is the 8th turn. 8 times 70 is 560 inches a minute. So you see, all you've got to do is look at the application, decide whether it's short circuit or spray transfer, and simply remember 10 o'clock, 17 cups of coffee, 3 o'clock, 27 cups of coffee. Note the 045 spray transfer requirements. Argon-oxygen mixers require a minimum of 230 to 240 amps. With argon CO2, you typically require more than 260 amps. The wire feed range is simple, 12 to 3 o'clock. Examine the 045 wire feed range. Make sure you pass the 12 o'clock position. Most welders weld between 1 and 2 o'clock. Once you go past the 3 o'clock position, the current may be too high, the weld puddle difficult to control. So the 045 wire feed range is limited normally to 12 to 3 o'clock. Examine the application. Welding 1/8 to 3/16, 3 to 5 millimeters. Start out at the 12 o'clock position. Welding a common 1/4 inch fillet weld, 1 o'clock. A 5/16 fillet weld, 2 o'clock. And if you're welding on heavy metals and you can weld in the flat position, 3 o'clock. The welding voltage range with the 045 wire is narrow. 26 to 33 volts is typical. 27 to 29 voltage is considered optimum. The weld voltage delivers the current and also establishes the arc length. Weld spatter occurs when the voltage is set too low. The wire runs into the weld, and this produces a harsh crackle sound. To set an optimum spray transfer voltage, start out with the voltage set too high, possibly 30 to 32 volts. This should produce a quiet spray sound. Then lower the voltage till a consistent crackle sound occurs without spatter.
Too high a voltage results in a quiet arc sound. The weld will be extremely fluid, producing an uncomfortable amount of heat for the welding operator. Smoke levels will rise as voltage increases. The results of too high an arc voltage are all too obvious. High volts will result in unacceptable undercut. Excessive surface oxides are also usually an indication of too high a voltage. Weld bead width increases as voltage increases, resulting in lower penetration. A longer arc length increases the chances of the weld droplet as it is traveling across the arc cap, picking up contaminants from the atmosphere. A noisy crackling arc sound is the result of low voltage. With low voltage, the wire is driven into the weld, disturbing the puddle, causing spatter. The weld bead will be narrow and convex in shape. Smoke levels will be reduced as the voltage is decreased. Notice the decrease in bead width and resultant increase in spatter.
Can you remember where we set the contact tip for short circuit welding? Slightly outside the nozzle, keep the wire stick out short. Spray transfer is the exact opposite. We should set the contact tip slightly inside the nozzle, maybe about 1/8 of an inch down inside the nozzle. Two reasons for this. One, we need a longer stick out because we no longer short circuit. And the other reason is we want to protect the contact tip from the intense heat. The wire stick out should be 1/2 to 5/8 of an inch in length. When you put the nozzle on, make sure the contact tip is slightly recessed.
Remember, when using spray transfer, the selection of your MIG gun is critical. Use the information previously provided under MIG gun selection earlier in this tape. Improper selection will result in early torch failure and a high nozzle and contact tip failure rate, which will also influence arc stability.
In this highly competitive industry, everybody tries to find a way to save a dollar. If you use spray transfer on 1/8 to any thickness in the flat and horizontal positions, then you can save some money by selecting an 045 wire instead of an 035 wire. You know, an 035 wire in spray transfer is fed at almost a feed rate of 10 inches a second. Now, with an 045 wire, the feed rate would actually be in the range of 6 inches to 8 inches. The slower the feed rate through the system, the less feed problems in general. We can also achieve the same high depositions by just increasing the current. We get very good arc stability, a slightly wider voltage coverage off the larger wire. All the economical sense is there. It costs less, it's better to use. So consider 045 wire for your next spray application. Let's have a look at a spray transfer. With spray transfer, start off with 27 to 28 volts. Remember, with the 045, set the wire feed at the 1 to 2 o'clock position. You know, if you're using a bigger wire like an 052, then you would set it back 11, 12 o'clock position. If you see spatter, increase the volts. If the arc is too quiet, decrease the volts.
By following the simple parameters suggested in this video, clean, spatter-free welds can be achieved every time.